We discuss about refraction of light, the model questions for our POLYCET. Here if it is given, if the speed of light in glass is 2 into 10 power 8 meter per second and in water it is given 2.25 into 10 power 8 meter per second is there. Okay. Then we have to find the refractive index of water with respect to the glass. Okay. Now, as the speed of light in glass it is given, that is of 2 into 10 power 8 meter per second, and speed in water is there. At first we convert that back into the refractive index values. Then from this we can write, we know that refractive index of water is equal to, which is of C by velocity or speed of the light in that water, that is. And in the same way, if you are taking refractive index of, in case of glass if you take, that is equal to C by velocity of that light or speed of light in that glass. Here we have to find the refractive index of water with respect to the glass. So means refractive index of water with respect to the glass, which means we are comparing the refractive index of water, okay, with the value of refractive index of glass, that is, okay, which is equal to refractive index of water by refractive index of glass, that is. Okay. As we know that mu is equal to C by V, that is, then refractive index of the glass with respect to water is equal to mu water, that is of C by velocity in water by mu C by velocity in case of the glass we are taking, like this. Then we get from this C by velocity of light in water into velocity of the glass by C, that is. Then C get cancelled and finally we get refractive index of glass with respect to the water is equal to velocity of the glass, which is velocity of that light in the glass is 2 into 10 power 8 meter per second, and speed given there another one which is 2.25 into 10 power 8 meter per second is given there. That meter per second get cancelled and that 10 power 8 get cancelled. Finally, we are getting refractive index of the glass with respect to the water. That refractive index of water with respect to the glass is 2 by 2.25. Or you can also write that 2 by 2.25, of which the refractive index of the glass with respect to the water as 200 by 225, that is. Okay, of which if you calculate that is of 25 fourths, and here you can take 25 eighths and 25 ninths you can take, 8 by 9. So the refractive index of water with respect to the glass, it becomes 8 by 9. Okay, if you observe there, the refractive index value is less than 1. Which prefers that the medium you are taking when compared to the water here, this glass refractive index is more because that is a denser medium, whereas water it is acting like a rarer medium here. So that's why we are getting the refractive index value when compared, we are getting less than 1. So given that a 4 centimeters tall object is at a distance 30 centimeters from the convex lens of focal length 20 centimeters is given. Now, at first when a numerical given like this, depending on the ray diagram we have, okay, first to find out the position of the object here. As focal length is given, f is equal to, focal length it is given as 20 centimeters, that is. Then as the focal length it is of 20 centimeters, then the radius of curvature position, which is nothing but 40 centimeters, that is. Means the center of curvature is at 40 centimeters. Then when come to the case of this object position is at 30 centimeters, that is. So u value is given, that is of 30 centimeters, that is. As the object distance is at 30, that 30 means in between, or that is in between the focus and the center of curvature position, that is. That is the position of the object here. Then if you take the position of the image here, we have to find here find the image characteristics formed here. Find the characteristics of image formed here. So image characteristics means finally we can say that is about whether it is a real or inverted or enlarged, that we have to find here. Like this we are having total 4 characteristics are there. About the nature of the image, about the inversion here, about the position of the object where it is formed, and finally we have to get the magnified or enlarged image, that is. Okay. Then to find that, we know that the formula of a lens formula, which is 1 by f is equal to 1 by v minus 1 by u, that is. Okay, as the focal length is given in this problem, which is of 1 by 20 centimeters is there, and object distance of which it is given, object is placed at 30 centimeters there. At first we have to find the image distance, that is. Then to get that image distance, at first if you apply the sign convention, to apply the sign convention, if it is a converging lens like this, a convex lens, the focal length it should be positive we have to take. The focal length of that is positive. And whereas the object distance if you are taking, as object is placed before the lens and the measured distance is against the incident light rays here, we have to take the object distance as a negative, that is, which is of minus, that is. Then finally it becomes 1 by f, 1 by 20 is equal to 1 by v, minus of minus here it becomes plus, that is, which is 1 by 30, that is. Then if you take 1 by v value, then 1 by v is equal to 1 by 30 coming this side becomes minus, which is 1 by 20 minus 1 by 30, that is. Okay. Then if you calculate that value here, 20 and 30, where LCM becomes 60, 23s and 32s, that is, then 1 by v value it becomes 1 by 60, that is. As 1 by v value is 1 by 60, then we are getting the v value, v is equal to 60 centimeters, that is. Here you get the image distance is 60 centimeters, that is. As we got 60 centimeters, if you observe there that object distance and the image distance, if you see image distance we are getting a positive value there, which means the image is formed after the lens here. So that's why here the image formed is a real image, that is. Then, and not only that, the size of the object which is given as a 4 centimeters is given there. As the object length is given which is of 4 centimeters, we have to find its magnification also. When come to the case of magnification here, we know that m is equal to v by u, that is, okay, of which m is equal to v by u. Then if you are taking the magnification, m is equal to v by u, where that v image distance which is given as 60 and object distance it is given as 30, that is, which is of 30, that is. And object distance, if you apply the sign convention, object distance it is of minus and image distance that is of a positive, that is. Then m is equal to minus of 31 and 32 square. Magnification value we are getting minus 2, that is. So magnification value minus 2 means here that minus represents the image formed is an inverted image, that is. So this minus represents the image is formed is below the principal axis, that is. Okay. So finally we got two important characteristics here, that is, when object value we are getting, object distance case that we are getting a plus 60 means the object is formed after the lens, as it is in the direction of the incident light rays here, the image distance value we are getting that as a positive, which represents that is a real image, that is considered as a real image, that is. And not only that, from the magnification it is clear that we are getting a negative value here, whereas that negative represents the image formed is below the principal axis we have. So means that is going to be inverted image, that is going to be inverted image. And another important thing is, as the object distance it is of 30 centimeters is there, here the image we got 60 centimeters, which is after more than the center of curvature distance we have, because the radius of curvature value is 40 centimeters is there. So which means that that image formed which is 60 centimeters is beyond the center of curvature position, that is. So means the image position is beyond center of curvature, that is. Okay. Now as m is equal to minus 2 we got, then if you take the minus m there, m is equal to, which is height of the image by height of the object, because the heights are given, that is of object height it is of a 4 centimeters tall is given there. Then m value we have minus 2 is equal to height of the image by height of object, then height of the image by height of object is given as 4 centimeters, that is. Then height of the image, from this it becomes minus 2 of 4 centimeters, that is. Finally, we get the height of the image is equal to minus 8 centimeters. That minus represents that is below the principal axis, and the size of the image we are getting is 8 centimeters, that is. So, if you are taking an object which is of 4 centimeters tall, the final image I am getting there is 8 centimeters, that is, which is a magnified image we are getting. So, the final characteristics here, that is of here an enlarged or a magnified image is formed. These are the image characteristics we got when the object is placed at 30 centimeters before the lens having the focal length of 20 centimeters is there. It is forming a real image and it is getting a inverted image, and the position of the image formed is beyond the center of curvature, as it is above the center of curvature position, which is more than 40 centimeters we have. And not only that, the image formed is an enlarged image. That's why here we are getting the magnification value more than 1 we have, and we are getting the final value height of the image is 8 centimeters, which is 2 times more than the size of the object we have. And another important thing is we got here that minus represents the image formed is below the principal axis. Okay. So, these are the image characteristics we got: real and inverted, beyond center of curvature, and enlarged image, that is. Now, you see one more question here, that is, a needle placed at 45 centimeters from the lens forms an image on the screen placed at 90 centimeters on the other side of the lens sphere. Then identify the type of lens and determine its focal length. So, at first we have to decide which type of lens we are using. So, for that we are having a clue here given that a needle placed at 45 centimeter from the lens means that object is placed before the lens sphere, forms an image on the screen placed at 90 centimeters, which is on the other side of the lens sphere, means object is on one side of the lens and image it is forming on the other side of the lens. If the image is formed on the other side of the lens, always that is considered as a real image. Then it when come to the case of the real images are formed only by the convex lens sphere. Concave lens image characteristics, we already know that they are always forming a diminished image, virtual and erect image, which means those images are formed before the lens only here. But here it is clearly mentions that the image is forms an image on the screen placed on the other side of the lens sphere. So, as it is given that is of other side of the lens is clearly mentioned there, the obviously that nothing but the convex lens only given there. So, the identifying the type of lens means that is going to be a convex lens, that is, which is a converging lens, that is a convex lens, and we have to determine now its focal length, that is. So, as it is of given focal length there of which 1 by f is equal to 1 by v minus 1 by u there. Then for that given the object is placed at 45 centimeters from the lens. So, that we call that as object distance, that is, which is 1 by that is of 45 centimeters is given. And not only that, the image formed, which is that image we are taking that on the screen, that screen placed at 90 centimeters on the other side of the lens. Even that is also that screen also taken from the lens only, of which we call that as image distance, that is, which is equal to 90 centimeters, that is. So, finally we have 1 by f is equal to 1 by 90 minus 1 by 45. Now, we have to apply the sign convention here. Then as the given one, it is about a convex lens, because the image is formed on the screen, and not only that, it is forming after the screen here, after the lens here, which represents that is going to be a real and inverted image, that is. So, that is why here the sign convention for the convex lens, where the image distance we have to take that as positive, that is, because that is forming beyond the lens, that is. The incident light ray direction and the object distance direction measured, both are in the same direction we have. Whereas the image distance we have to take that as, object distance we have to take that as negative, that is, because the object is placed before the lens. So, that is why it is against the opposite to the direction of the incident light rays, we have to measure the distance of the object. That is why we have to take that as negative for that. Then finally, we got 1 by f is equal to 1 by 90 plus 1 by 45, that is. Then if we take LCM here, then 1 by f is equal to 90 and 45, then 1 plus 2, that is, which is 3 by 90, that is. Okay. Then finally we got the focal length f is equal to 30 centimeters. But if you observe here that focal length we are getting which is of 30 centimeters is a positive one, that is. So, as focal length is positive, from this also we can say the image formed is a convex lens image formation, that is, because the convex lens focal length is a positive one. So, that is why here also we are getting a convex lens, that is, which is the focal length value is positive sign convention we have. Now, given one more problem here we have a 10 centimeters tall object is placed at a distance 20 centimeters from a convex lens of focal length 30 centimeters, that is. Here we have to find the position, nature and size of the image formed here. Okay. Now, given that if you observe the 10 centimeter object is placed at a distance 20 from convex lens whose focal length is 30, means that as the focal length is 30 and object distance is less than that focal length which is 20, then object is placed in between focus and optic center, that is, and that we are using a convex lens. So, which means about that sixth special ray diagram, that is, of which here we are getting a virtual and erect image we are getting, and not only that we are getting a enlarged or magnified image we are getting. Okay. Then as we are taking that f value given there which is of 30 centimeters and object distance that is of u given 20 centimeters, that is, and not only that given that is of placed in between f and c, f and optic center given there, then 1 by f is equal to 1 by v minus 1 by u, where 1 by f is equal to v value we do not know, and object distance that is of given which is 20 centimeters, that is, and focal length given that is of 30 centimeters is given there. Then if you apply the sign convention here according to the rules we have to apply. So, that the focal length value given it is of 30 centimeters which is for the case of convex lens, that is a positive we have. Whereas, in case of this object distance, if you are taking the sign convention as object distance we are measuring against the incident light ray direction here. So, that is why the sign convention for object distance is minus, that is. Then 1 by 30 is equal to 1 by v minus of minus becomes plus 1 by 20, that is. Then finally we got 1 by v is equal to 1 by 30 minus 1 by 20 here. Then 1 by v is equal to and 30 and 20, whereas LCM it becomes 60. Then 30 into 2 minus 3 here, 2 minus 3, that is. Then 1 by v is equal to minus 1 by 60 we got. Therefore, finally we got the image distance is nothing but equal to minus 60 centimeters, that is. So, the image distance v is equal to minus 60 centimeters, that is. But if you observe here, usually convex lens we are getting the image distance values as a positive. But here very rare case we are getting a negative value here, because this is the special case here, because as the object is placed in between focus and optic center here, it is forming an erect image and virtual image which is formed before the lens only, which means in the same direction as object say aside we are getting the image is formed. So, that is why as the image that the object it is of minus, even the image also we are getting that as a minus here. Okay. So, that minus represents the image formed is an virtual and erect image, that is. Okay. Now, as we got the image distance, now we can find the magnification here. So, whereas that magnification m is equal to which is minus v by u we have to take, where that vu that is given which is of given is 20 and image distance that is we got that as a 60, that is. As object distance it is of minus, okay, and in this case particularly the object distance and image distance both we have to take that as minus, because both are on the same side we have about the special case. Then both get cancelled here, where we are getting 3, that is. So, magnification value we are getting plus 3, that is. So, plus represents that is above the principal axis, which means that is virtual and erect. This plus represents that is virtual image and erect image, that is. And 3 represents which value, that is of m greater than 1, which means that is a magnified image it is formed. So actually these are the image characteristics we have, that is of image distance is formed at 60 centimeters on the same side as we got here minus, and here that is nothing but that plus becomes the virtual and erect image, that is, and m value if it is greater than 1 means that is a magnified image, that is. Then if you find how much is the size of the image it is forming, as we know that given that the object height it is of 10 centimeters tall is given there, and now only we calculated m value which is 3 we are having. Then magnification formula, then height of the image by height of object is equal to 3, then height of the image by height of object it is of 10 centimeters tall, that is, then height of the image becomes 3 into 10 30 centimeters, that is. So the height of the image formed here it is equal to 13 centimeters, whereas if you are taking the object size is only 10 centimeters, we are getting a magnified or enlarged image which is taken as 30 centimeters, that is. So finally the image characteristics and the nature of the image formed here, that is of virtual, erect and a magnified image, that magnification is 3 times we have, that is why the size of the image formed here it is 30 centimeters, and the position of the object is on the same side as we are getting minus here, and we are getting minus 60 centimeters on the same side of the object only we are getting. Now given another one, given question is, how far must a girl stand in front of a convex lens of radius 120 centimeters to see an erect image of her 4 times its natural size, that is. Okay. So he want to see her 4 times the magnified image there, so that here the radius of curvature is given as 120 centimeters, that is. As the radius of curvature r value if it is given as 120 centimeters, then we know that r is equal to 2f, that is. Then f becomes r by 2. Where r by 2 means that is of 120 by 2 centimeters, that is. So finally the focal length here it is used is 60 centimeters, that is. And now the question is given, that is magnified image she is getting, whereas that is an erect image is formed. And if you observe here, the lens we are using is a convex lens, and here we are taking for the case of erect image. Convex lens forms the erect image only in one case, if the object is placed in between focus and optic center case. But here the magnification as it is given as 4, then m value we have to take that as 4, that is, and that too as that is of erect image there plus 4 it becomes. Then m value it is of m is equal to v by u is equal to 4, then v is equal to 4 times u, that is. So if object distance if you are considering, then image distance is going to be at 4u, that is. Then if you apply that formula here, 1 by f is equal to 1 by v plus 1 by u, that is, then 1 by f, where the focal length given which is of 60 centimeters and the image distance which is of 4 times the u, that is, plus object distance we are taking that as u, that is. Then if you apply the sign convention here, then 1 by 60 is equal to then 4u and u, 4u is that, then u plus 4 here, okay, of which 4u we are getting that as 1, okay, and u is there, 4 you will get the LCM, that is. Then 1 by 60 is equal to 5 by 4u, that is, then 4u is equal to 5 into 60, then object distance u is equal to, if you are taking 15, that is of 75 centimeters, that is. Okay. Then we got object distance, one possibility that is of 75 centimeters is there. Okay. Then so that we are getting here the image formed which is u is equal to 75 centimeters, that is. Okay. Now as the object distance is at 75 centimeters, therefore the image distance v is equal to here 4 times that u, that is. Then if you take that 4 times that u, then 4 times of object distance, that is, which is 75, that is, which is of 300 centimeters, that is. Okay. Then v is equal to 300 centimeters, that is. This is the case if you are taking, if the object, if you are assuming that is of taken before the convex lens here. And finally we got the object distance, it is of 75 centimeters. But in this case it is given that focal length is 60 centimeters and here the image formed is an erect image is forming. Then as it is the erect image here it is forming, then we have to take the object distance also as negative here, because this is about the special case. If the object formed is a real image, then we have to get the values as u is equal to 75 and v is equal to 300 centimeters there for the usual sign convention here. But as it is given that is of erect image, we slightly change our sign convention here. Then 1 by f is equal to 1 by v plus 1 by u here. Then 1 by focal length, that is of 60, is equal to 1 by v, which is u. Object distance, that is 1 by v minus 1 by u, that is, and here object distance, that is of image distance is 4u, object distance is u, and if you apply sign convention, object distance is of negative, minus of minus becomes just like here plus, but as it is the erect image is forming, image distance no more it is positive here, of which if you are considering that as a real image, then we are getting that as a positive, but here in this case it is taken as negative here, that is of minus 4 we have to take there. Then if you take that 1 by 60 is equal to minus 1 by 4u and minus of minus plus 1 by u, that is. Then 1 by 60 is equal to, then again if you take LCM it becomes 4u, and again you are taking that minus 4u means minus 1 plus 4, that is. Then 1 by 60 here it is equal to 3 by 4u, that is. Then again if you cross multiply that, then 4u is equal to, then you are getting that 4u is equal to, that is of 180 centimeters, that is, and u is equal to from that 180 by 4, which is 45 centimeters, that is, okay, as that is of 45 centimeters, that is, okay. Then if you are taking that, as the object distance and image distance, if you observe, object distance we got, which is 180 by 4, which is 45 centimeters, that is. Then from this image distance becomes v is equal to 4 times u, that is, which is 4 of 45, that is, okay, which is 180 centimeters, that is. If you observe in this case, the object distance we got 45 centimeters, which is the focal length is 60 centimeters, that is. Focal length is 60, but object distance is 45. So means that object is placed in between focus and optic center. So when you are taking the sign convention for the image distance, which is taken as negative, we got the object distance is at 45 centimeters. Earlier we done, if you are taking this object distance as positive, of which we consider that as a real image, there we are getting the object distance, it is of 75 centimeters, that is beyond f we are getting that. But here in this case, as our given problem it is given that is of erect image is given, as it is about erect image means the object and the image both are on the same side. So that's why we are using the sign convention minus here. So that's why we got the object distance is less than the focal length value, which is 60 centimeters we got. Okay. So u is equal to 45 and v is equal to 180 centimeters we got. Okay. This is the object distance and this is the image distance. So according to our given question there, how far must a girl should stand in front of this convex lens of radius having 120 centimeters to see the erect image of her 4 times its natural size? Then where she has to stand is the object, which is nothing but the girl here. She has to stand 45 centimeters from the mirror so that she can see her face 4 times more than the original size here. And that too here it is forming a virtual image. So that's why this image is formed backside of the lens here, which is before the lens only it is forming, that is. Now next one given about the thick lens here, which is of lens maker formula based, that is. A biconvex lens has same radius of curvature or for its faces. So means R1 value, R2 value, both cases we are taking the same value as R, that is R1, R2, both cases that is taken as R, and if the focal length of the lens in the air is R by 2, that is. So means after the combination of the lens here, that combined focal length it becomes f is equal to given R by 2, that is. Then the refractive index of the lens is, means we have to find the refractive index of the lens, n is equal to how much. Then we know that as it is of lens maker formula, given that is about a thick lens here, the convex lens here, then we know that formula is 1 by f is equal to n minus 1 half 1 by r1 minus 1 by r2, that is 1 by r1 minus 1 by r2 here. Then if you substitute the values given there of which 1 by f is equal to r by 2 is equal to n minus 1, we don't know how much is n, where n is about the refractive index here, and 1 by r1, which is 1 by r1 value, the radius of curvature is taken as r, minus 1 by r2. In that case also we are taking the radius of curvature is r, that is. Then in this case, if you apply the sign convention of which bring this 2 to the numerator, then 2 by r is equal to n minus 1 of, then as given it is about a convex lens here, a convex lens, then if this surface, if you are taking the light ray incident, that is going to be the r1 there, and r1 it is like a convex surface. For convex surface, as the focal length it is of a positive, that's why r1 that becomes a positive, that is. Whereas once the light ray enter into the second medium here inside that lens there, then the second medium, second surface, it is acting like a concave, that is, which is r2, that is. So as it is of like a concave focal length, it is of negative, that is. So r2 value becomes minus r, that is. Then finally we got 2 by r is equal to n minus 1 of 1 by r minus of minus, which becomes plus 1 by r, that is. Then 2 by r is equal to n minus 1 of 1 by r plus 1 by r, which becomes 2 by r, that is. Okay. Then this side we have 2 by r, that side also we are having same 2 by r is there, that 2 by r get cancelled, so that we get n minus 1 is equal to 1, and finally we got the refractive index here, n value it is equal to 1 plus 1, 2, that is. So means when you are taking a lens having the same radius of curvature r and r there, and the focal length here we are taking is r by 2, that is, which is half of the r value here, then if you substitute that, finally we are getting the refractive index of the given material here, which is the lens, that value n value we are getting that as 2, that is. Now given one more problem here, that is an object located 32 centimeters in front of a lens forms an image on a screen 8 centimeters which is behind the lens, that is. So the main important thing here we have to see is, here it is given no lens is there, okay, of which we don't know which type of lens that is. And not only that, it is clearly mentioned that the image which is forming on the screen, that it is of 8 centimeters, that is, on a screen where 8 centimeters, and that too it is placed behind the lens, that is. So means the screen is nothing but the position of the image where we are getting, and object position is also given there, which is of 32 centimeters, that is. So given values are object it is of 32 centimeters there distance, the image is formed at 8 centimeters there, and it is forming behind the lens, that is. So means on the same side of the object. And here we have to find the focal length of the lens, the magnification, and we need to find whether it is a converging lens or diverging lens, that is. So how to find that is a converging or diverging lens means depending on the nature. If you are having a converging lens is there, then we are having the focal length positive will get, and if you are getting a negative focal length there, that is having a diverging nature we have. Okay. Then first find out what about that focal length here, to find the focal length. Then as you know, the u value and v value here, 1 by f is equal to 1 by v minus 1 by u, that is. Then 1 by f is equal to, then 1 by v, where v it is of 8, and 1 by 32. But here you have to observe that that image is formed, that screen is placed behind the lens here. Okay. As the image it is forming there in this case, which is of behind the lens, that is. So that's why here we have to take the image distance also as negative here. Both are of same we are taking, that is. Okay. Both the cases we are taking that as minus, that is. Then 1 by f is equal to, here in this case, object distance that is of always negative we have. Then 1 by f is equal to minus 1 by 8, and minus of minus becomes plus 1 by 32, that is. Then if you take LCM here, 1 by f is equal to 1 by 8 and 32 here, 32 is the LCM, then minus 4 plus 1, that is, which is minus 3 by 32 that is. From this we can write the focal length value f is equal to minus 32 by 3 that is, which is equal to minus 10 of here 10.66 centimeters that is. So we got the focal length value f value as minus 10.66 centimeters that is. As the focal length value f is equal to minus, that minus represents, that is about the case of diverging nature it has. As having the diverging nature it is meant only for the case of concave lens that is. So that's why we got the first one, which is finding the focal length. The focal length value it is of minus 10.66 centimeters. And when come to the case of is the lens converging or diverging, means as minus it is there, then it is considering as a diverging lens that is, which is a concave lens that is. Because the sign convention of focal length for the case of concave lens is negative. So that's why it is a diverging lens that is. That is a diverging lens. Now if it come to the case of magnification, where magnification m is equal to v by u that is. Whereas v value we already given that is of 8 centimeters and object distance that is of 32 centimeters that is. And not only that, object distance we have to take that as negative, and image distance in this case that is again negative that is. That minus minus get cancelled. Finally we got m is equal to 1 by 4. And if you observe here that m value we got positive value here. This positive represents that is an erect image or virtual image that is. And not only that, that value we are getting m value which is less than 1 we are getting. As m value it is less than 1, then it is considered as a diminished image. This is considered as diminished image. Okay. So finally, as the m value is equal to plus 1 by 4, we can get that magnification factor, which is m is equal to 1 by 4, which represents that is an erect image, a virtual image, and not only that, it is a diminished image, because we are using a concave lens here, which is a diverging lens that is given the focal length in terms of focal length here, whereas convex lens it is given in terms of power here. Then what we have to find is what is the resultant power and the focal length here. So we have to find both the focal length as well as the power here. As the first case it is given the focal length value, which is of for case of concave, f1 is given as 50 centimeters. But here concave lens, that is a diverging lens. So for diverging lens we have to take that focal length as -1 that is, which is minus 50 centimeters that is. As the focal length is minus 50 here, then its power becomes P is equal to 1 by F, that is, of which we are having a minus is there for that focal length here, minus F. Then P1 is equal to 1 by focal length, which is 50, and with a minus. But here this is in centimeters we have to convert that into meters. Then P1 is equal to minus 1 by 50 centimeters. We can write that as 50 by 100 meters, that is. Then it becomes F and P1 is equal to 100 by 50, that is. Okay, that is of meter inverse means diopter, that is. So finally we got P1 is equal to 51s and 52s plus 2D. Okay, P1 we got plus 2D, that is. Okay, and after that we are having that convex lens, which is the combination lens we are having, that is of minus 1.5 is given there. So we got the pressure, we got the power P1 is equal to 100 by 50, which is of 2, and the sign convention here, as it is a concave, that is taken P1 is equal to minus 2D, that is. But here another lens, convex lens we have, which is the combination lens, that is 1.5 is added to that combination. Then finally that P2 value, which is plus 1.5 D we have. Okay. Then as the combination of the power here, the resultant P is equal to P1 plus P2, that is. Whereas P1 is minus 2D and P2 is 1.5 D, that is. Okay. Minus 2D plus 1.5 D, it becomes minus 0.5 diopters, that is. that is the final resultant power we got, which is minus 0.5 D. And again we are having a minus is there, which means that that is going to be the diverging lens, that is. Okay, then as P is equal to, we got minus 0.5 D, we have to find the resultant focal length also. We got the power, now we are finding the focal length here, where that focal length F is equal to 1 by P, that is, which is the reciprocal, both power and focal length are reciprocal to each other. Then it is equal to 1 by, as power is minus 0.5 and it is of given diopters, that is, where diopter is a reciprocal of meters, that is. So 1 by minus 0.5 by 1 by meter, that is. Then minus 1 by 0.5, which is a 5 by 10, that meter come to the numerator, that is. So 5 ones, 5 twos, it becomes minus 2 meters. That is the focal length resultant, where F is equal to minus 2 meters, that is. Or we can also write that as minus 200 centimeters, that is. Okay. So now we got the resultant power, where that power is equal to minus 0.5 diopters and the resultant focal length becomes minus 200 centimeters. Then if the object is moved further away 8 centimeters away from the lens, means we are increasing the object distance in between F to O to, it is moving away from the focus here. So that in this case it is getting a real image, but given the condition that same size of virtual image is formed, so the size remains same here. Okay. So which means that first the object is placed, if this is the convex lens, first the object is placed in between F and O, so that in between that it is formed, which is of 12 centimeters is given. Now it is moving away by 8 centimeters is given, so that the position becomes in between C and F now. This is the first position of object and this is the second position of the object. Due to the case of first position of object and second position of object, let us suppose for the position of object U1 here, okay, this is the object distance, and let us suppose the image distance corresponding to that is V1 if you take, then second case U2, then image position becomes V2, that is. So, but in the case of that U1 case, as the object it is of near to the lens here, the image formed is an erect image, which means on the same side only we have. So, that is why the sign convention becomes for the object distance and the image distance, it will become both cases of minus. But once the object it is moved away from that by 8 centimeters here, then object distance is negative, but image distance becomes positive, because in this case the image is formed is a real image. If it is a real image, then that image is forming behind that lens here, after the lens it is forming. So that is why here we are getting plus V2, that is. Okay. At first we got that sign convention. Now if you see the condition there, the condition given that same size as virtual image, means the real image formed there and the virtual image in the earlier case formed there. Both cases the magnification is the same, where that magnification here, that is equal to M is equal to V by U, that is. In the first case then V value we are taking that as V1, U value we are taking that as U1. Whereas in the second case, then M2 is equal to again V by U, where V it is of V2, U it is of U2, that is. And given that M1 is equal to M2, both cases same type of image only forming, means the magnifications are equal here. So V1 by U1 is equal to V2 by U2, that is. Where V1, that is about the image formed in the first case, where the object is placed at 12, and image distance V2, that is for the second case, is equal to object distance which is placed from the 12, it is moving away by 8, then 12 plus 8 it becomes 20 centimeters, that is. So this becomes 20. Then finally we got V1 by V2 value as V1 by V2 value, we got that as 12 by 20, that is, which is 6 by 10, or you can write 3 by 5. So V1 by V2 value we got 3 by 5, that is. Okay. Now according to following the formula here, lens formula, in the first case, in the case 1, where virtual image is formed, 1 by F is equal to 1 by V minus 1 by U, that is. Then 1 by F is equal to 1 by V, where V1 we are taking that as, and object distance it is of 12 centimeters we are taking. Then this is the first case we have, so that here in this case if you apply the sign convention, object distance is negative and V1 also negative. Then 1 by F is equal to minus 1 by V1 and minus of minus plus 1 by 12 we got for the first case. Okay. Whereas in the case of case 2, where we are forming here a real image is formed, then in this case again if you apply 1 by F is equal to 1 by V minus 1 by U, then 1 by F, focal length remains same because we are not changing the lengths given here. So the focal length remains same, 1 by F is equal to 1 by V, where V is the image formed here. That image formed we are taking that as V2, that is, and object distance as it is increased, which is from a 12 to 8 centimeters it is increased there. So that's why here it becomes 20 centimeters, that is. And not only that, as it is forming the real image here, the object distance is taken as negative as usual, but the image distance we have to take that as a positive, that is. So then 1 by F is equal to 1 by V2 minus of minus plus 1 by 20, that is. This is the second case we got 1 by F value, and this is the first case we got for 1 by F value. So given we got that from case 1 minus 1 by V1 plus 12, and case 2 we got 1 by F is equal to 1 by V2 plus 1 by 20, that is. And we got the relation between V1 and V2 is equal to 3 by 5, that is. Now if you use these equations, if you equate 1 is equal to 2, then 1 by V1 which is minus plus 1 by 12 is equal to 1 by V2 plus 1 by 20, that is. Then if you bring that, we know that V1 by V2 value is 3 by 5, that is. From this we can write V1 is equal to 3 by 5 of V2, that is. Then if you substitute that value here, then minus 1 by V1 value which is 3 by 5 V2 plus 1 by 12 is equal to 1 by V2 plus 1 by 20. Then here it becomes that 5 come to the numerator, so minus 5 by 3 V2, and bring that V2 this side becomes minus V2 is equal to 1 by 12 going that side becomes minus 1 by 12, that is. Then 3V2 and V2, if you take LCM, it becomes 3V2 there, then 3V2 which is of minus 5, and here it becomes V2 is there and becomes minus 3, that is. Okay, is equal to 20 and 12, LCM becomes 60, that is, 23 is and minus 5, that is. Finally we got minus 5 minus 3 which is minus 8 by 3V2 is equal to, and 3 minus 5 which is minus 2 by 60, that is. Then from this you can get here that minus get cancelled and here 3 get cancelled. Then if you cross multiply that, 20 into 4, 60 is equal to V2, that is. So V2 value we are getting plus 60 centimeters, that is. Because V2 is the image formed which is behind the lens it is forming. So that's why V2 value it is of plus 60, that is. And we know that relation to V1 and V2 is V1 by V2 is equal to 3 by 5, that is. Then from this we can write V1 is equal to 3 by 5 of V2 value which is 60, that is. Then it becomes 36 centimeters, that is. So V1 we got 36 centimeters, where V2 we got that as 60 centimeters, that is. Then once we got that V1 and V2 values, easily we can find the focal length here. Okay, so finally we got V1 value 36 and V2 value 60 centimeters, that is. Then if you substitute that value here in any of this equation, then again we are getting back our focal length value. Substitute the value in any of the equations V1 or V2 here in equation 1 or equation 2. For example, if you are taking for the case of second one, 1 by F is equal to 1 by V2 plus 1 by 20. This one after applying the sign convention. Then 1 by F is equal to 1 by V2 value we got that as 60 plus 1 by 20, that is. And 60 and 20 again LCM if you take, which is of 60, that is, here 1 plus 3, that is of 1 by F. Then 1 by F is equal to 4 by 60 which is 1 by 15. Therefore, the focal length here we are using is 15 centimeters, that is, and we are getting plus because we are using a convex lens, that is. Okay. So, the one which is having the object distance which is taken at 12 centimeters, when object is in between F and O, that is, because the focal length it is of 15 centimeters, that is, as it is of 12 centimeters is the object distance here. For the case of this convex lens, we are getting a virtual image. Whereas in the second case, if we are taking as the focal length it is about 15 centimeters and object is moved 8 centimeters away, then 12 plus 8 it becomes 20. Then the position of the object is changed here, which is now it is becoming in between the focus and center of curvature, that is. Then in this case, then what happens there is again we are forming a enlarged image there, but that enlarged image is same size as virtual image enlarged image, that is. By using that condition, if you find that we are getting the focal length of which is 15 centimeters there, and we got the object distance and image distance. Object distance it is of 15, 12 and 20 we have. For that correspondent image distances we are getting that as V1 is 36 centimeters and V2 we got 60 centimeters, that is. Here another MCQ will see a multiple choice question given that the image formed by a concave lens of a real object is larger than the object there. Okay. So, which means the whatever the image given here, it is size it is having more than the size of the object we have. And but if you see here the image formed by concave lens here, that concave lens, if you see the ray diagrams, we are having only two ray diagrams we have, of which when you are taking a concave lens at infinite distance, when the object is at infinite, here we are getting the image there which is formed on the same side, a virtual image is formed at the focus there. Okay, like this. Whereas in case of any finite distance, if you take the image formed here, it is always anywhere you take the object position, always the image is formed on the same side there like object. And not only that, actually here the image formed is a diminished image we are getting, a virtual and a diminished image we are getting. These are the ray diagrams we have in case of this a concave lens, that is. Okay. But here in the given option there, the size of the image it is more than the size of object is given. At first that is wrong, because the concave lens always forms the image which is less than the size of the object only given there. But here it is given that concave lens of the object forming larger than the object size, which is not possible here. Anywhere you take the object in between from infinite to up to the lens here, anywhere you take, always it shows the same type of characteristics here, that is of it is forming always a virtual image and erect image, that is, and not only that, it always forms it is of diminish in size image, diminish in size, and not only that, it is forming on the same side as object, same side as object, that is. Okay, virtual, erect, diminish and same side. For any case, these are the image characteristics we have. But whereas in the given options that is given, that is of question, larger than the object is given, which is never possible. So that's why here anywhere you take the object distance greater than 2f, less than 2f if you are taking, which means in between center of curvature to the lens, that case also diminished image, and u greater than 2f, which means the object is placed in between infinite and center of curvature position, even that case also we are having diminishing image there. And any value of u you can take from the infinite up to the optic center, you take anywhere in between that if you are taking, in that case also we are having the same diminution size image only we have. So that's why of the given options, A, it is not possible to get larger object, and B, it is not possible, any value of u also not possible. So the correct option is for no value of u, because object anywhere you keep, but it will never forms a enlarged image. Okay, in case of concave lens, that is, because concave lens always forms the same type of characteristics, formation of virtual, erect and diminishing size only. Anywhere you can take the object. So that's why in this given question here the answer is for no value of u, we are not getting any image there which is like larger than the size of the object. Actually, in the given question, we noticed mainly two important things. They didn't give any particular lens here, and another important thing is it is forming upright image, and the size is, if you see, 1/4 of the object. Upright image means the erect image, that is, which is virtual or erect, that is. This is erect image, and not only that, size is 1/4, which means that is a diminished image, that is given as a diminished image. So, here given mainly the characteristics are, it is an erect image, all erect images are virtual images, and not only that, it is forming a diminished image, that is a diminished image. Now, with these characteristics having virtual, erect and diminished, it is formed by only one lens, that is a concave lens, that is. Okay, the formed one is a concave lens, that is virtual, erect and diminished image, that is. So, now we are taking that as the object distance is given as 25 centimeters there, as object distance equal to 25 centimeters, and magnification factor it is given as 1/4, that is. Then as m is equal to 1/4, then m is nothing but v by u, which is equal to 1/4, then v is equal to u/4, that is. Okay, as m is equal to 1/4, then v becomes u/4, that is, which is nothing but equal to 25/4, that is. Then if you are taking the focal length formula here, 1/f is equal to 1/v minus 1/u, then 1 by the focal length value we don't know, and image distance, that is taken as u/4, which is 25/4, that is 25/4, minus 1/u, object is at 25 centimeters, that is. Then 1/f is equal to, from this, that 4 coming to the numerator, 4/25 minus 1/25, that is. Then if you apply the sign convention here, as it is of given that it is forming erect image or upright image, erect images are formed on the same side of the lens here. So, that is why here, as it is formed on the same side of the lens, which means that object and the image, both cases we are having the same sign convention is present. So, that is why for the object distance it is minus, even for the image distance also it is taken as minus here. Then we will get 1/f is equal to here minus 4/25 and minus of minus plus 1/25, that is. Then we got 1/f is equal to 25 of minus 4 plus 1, that is, which is 1/f is equal to minus 3/25. Okay. Then what we need is, here we have to find the power of the lens here. So, power of the lens P is nothing but 1/f, that is. So, that 1/f value we got minus 3/25, that is. But all this is this focal length we are taking in centimeters, that is. Okay. So, that is why here we have to take this power, this focal length in terms of meters we have to take. Then 3/25 of, okay, of which in centimeters, if we convert that into meters, so we have to multiply that with 1/100. So, 25 into 1/100, then it becomes 1/meter, that is. Then minus 3 of that 100 come to the numerator by 25 diopters, that is. Then it becomes 25/4, that is, of which the power of the lens we are using P is equal to minus 12 diopters, that is. Where that minus represents the focal length, it is of negative, that is, if the focal length is negative, then the power becomes negative, that is, and that negative it is meant for the case of a given concave lens, that is taken as a concave lens, that is. Okay. So, for this given problem, the lens we are using is a concave lens, and the power of the lens it is equal to minus 12 diopters, that is.